Just like sine and cosine, tangent and cotangent can have a vertical shift. It can be vertically stretched. They can both have a change in period, and they can both have a phase shift. To graph them, we will start similarly to how we did sine and cosine graphs. We will find all of the x values, and we will find the start and end of the period. For tangent, we will use the original starting and ending values of the asymptotes. We will put whatever's inside of the tangent function, we will place that between minus pi over 2 and positive pi over 2. For cotangent, we will take the input values and we will put it in between its two asymptotes, which would be 0 to pi. So once we solve those inequalities, that will tell us where we start and end for tangent and cotangent. Keep in mind that the endpoints here are the asymptotes. Second, we will find the midpoints. And we will add together the endpoints and then divide by 2 or multiply by 1/2. After we find the midpoints, then we will indicate our vertical shift by drawing a dotted horizontal line for the new middle of the graph. A used to be amplitude for sine and cosine, but for tangent and cotangent we don't have an amplitude. All we have really is a vertical stretch. So we will stretch the graph vertically from the middle. So wherever our middle of our graph is indicated by the vertical shift, the vertical stretch from the points will be indicated by A. And then we will draw the basic shape of tangent or cotangent within their asymptotes. For this graph of tangent, we have y equals 1 plus tangent 1/2 of x. We see that we have a vertical shift. The vertical shift, we have added a 1 to the outside of the function, so the new middle of the graph will be at y equals 1. We also have multiplied the inside of the function by 1/2, which is going to give us a change in period. So this was our c, this is our b. Since the original period of tangent is pi, we will divide pi by b to get the new period. So pi divided by 1/2, we will flip and we will multiply. So we end up with a period of 2 pi. There is no phase shift, and there is no vertical stretch. So we would say A is 1. The first step to graphing tangent is to find the starting and ending points for the period. Tangent originally starts and ends between the x values minus pi over 2 and positive pi over 2. These are the original asymptotes. We're going to take the input of our function 1/2 x and place it in between them and solve for x. So we need to multiply by 2 to get x by itself in the middle. And when we multiply by 2, think about that as 2 over 1. The 2's cancel. We have minus pi less than or equal to x less than or equal to pi. So the starting and ending asymptotes now will be minus pi to positive pi. Now that we know where the graph starts and ends, let's find the midpoints. So we're going to add together minus pi plus pi, which would be 0, and then divide that by 2. Well, I still get 0. So keep in mind that this would be now our y-axis, where x is 0. And our other midpoints, we're going to add together, divide by 2, we get minus pi over 2, and 0 plus pi would be pi, and then we divide that by 2. So here we have our midpoints. Now the graph, this period, this 1 period interval of tangent starts and ends at its asymptotes. So we're going to draw in dotted vertical lines to represent the asymptotes. Remember, this is where tangent, this definition of tangent here, this equation of tangent is undefined. And then we're going to draw in our shape of tangent. First, let's put in our vertical shift, because we said we had a vertical shift, and that is at a y value of 1. So the middle of my graph now is right here at this y value of 1. This is the new middle. So that vertical shift shifts the middle of my graph up. And to draw in the basic shape of tangent, we will have one point at the very middle of our graph, and then at this next midpoint we will go up 1 unit, so we will be at 2. So we go to the right to find that midpoint, and then we go up 1 unit. And from the middle we will go to the left midpoint, and then we will go down 1 unit. So the graph of tangent starts at the middle, goes up to the right, and then goes down to the left. So the A represents the distance from the middle of the graph to the first point, and from the middle of the graph to the point on the left. So if our A is something different, then our graph would stretch or shrink vertically according to what the value of A would be. To graph cotangent, we have y equals 2 times cotangent of 3x. We have no vertical shift, so the middle of my graph will be at the x-axis, y equals 0, just like the original. We do have a change in period. We see that the inside of the function is being multiplied by 3, and so b is 3. So this is our a, this is our b, and b is 3, so the period of this cotangent function will be pi over 3. So we have no vertical shift, and our period is pi over 3. And we said we multiplied the front of the function by 2, so our vertical stretch will be 2. So the distance from the middle of the graph to the first point on the right and the middle of the graph to the first point on the left will be 2. So that's our vertical distance between points. We have no phase shift. We have not added or subtracted anything on the inside of our function. So when we go to draw our graph, the first thing we want to know is where does our graph start and end. The original starting and ending values for cotangent are 0 and pi. These are the two asymptotes that we started with on either end of our period of our basic shape of cotangent. So we will take the input for our function, 3x, and we will solve for x. So dividing each part by 3, I get 0 is less than x is less than pi over 3. So we know that we're going to start at 0 and that this 1 period interval of cotangent will start at 0 and end at pi over 3. Let's find the midpoints, add together, and multiply by 1/2. We get pi over 6. Add together, multiply by 1/2, pi over 12. Add together, be careful, we need a common denominator. What would this be with a common denominator? Multiply top and bottom by 2. Add together, we get 3 pi over 6, which is pi over 2, and then multiply by 1/2, pi over 4. So these are our midpoints for our cotangent graph. We will draw in our asymptotes. That's where the graph would start and end. So now we have our asymptotes where we start and end this 1 period interval of cotangent. So we've taken care of the period, we've taken care of the phase shift, and we have no vertical shift, so we're still on the x-axis for the middle of our graph. So when we go and graph cotangent, at the middle of the graph we're at 0. Remember, cotangent goes in the opposite direction of tangent, so we're going to go to the left and up. And how many units do we need to go up? Let's talk about that. Well, our A is 2. That means our vertical stretch is 2. So we need to go up 2 units. So to the left, the regular value of cotangent would be to the left and up 1 unit. But because we have a vertical stretch of 2, we're going to go to the left and up 2 units. And then the same thing for going down and to the right. So cotangent goes to the right and down. We're going to go down 2 units this time. So my cotangent graph looks something like this. And the A tells me, once again, if I go up, it tells me to go up 2 units to the left. And then if I go down, it tells me to go down 2 units to the right. For this equation, y equals tangent of x minus pi over 4, it looks like all we have done to the inside of the function is subtract pi over 4. So the only difference that we're going to have from the original graph is a phase shift. And once again, the phase shift goes in the opposite direction of the sign. So adding or subtracting a value on the inside of the function changes the phase shift. So we're going to go positive pi over 4 units to the right. The period is still pi. We haven't multiplied the inside of the function by anything. So when we go to graph this, we need to figure out where we start and where we end. And the original graph of tangent was in between negative pi over 2 and positive pi over 2. So we're going to take the input of our function, x minus pi over 4, and we're going to solve for x. We're going to add pi over 4 to both sides. And so that gives us x in the middle. We do need a common denominator, which would be 2 pi over 4. So when we add these values together, 3 pi over 4, negative 2 pi over 4 would be the common denominator. And we end up with negative pi over 4 for our left asymptote. So we have negative pi over 4 as our starting asymptote, and the ending asymptote will be 3 pi over 4. Let's go ahead and put in our dotted vertical lines to represent the asymptotes. And let's find the midpoints. So minus pi over 4 plus 3 pi over 4 would be 2 pi over 4. We can reduce that. Pi over 2, and then multiply by half, so we get pi over 4 as our midpoint. Notice that between minus pi over 4 and pi over 4 we change from negative to positive, and the x-axis will be directly in between those two because they're the same number but opposite signs. So here's our y-axis. Alright, so in between them, of course, the midpoint here would be 0. And here, when I add these two values together, we get 4 pi over 4, which reduces to pi, and then divide by 2 or multiply by 1/2, we get pi over 2. So those are our midpoints. We have taken care of the period, the period, which was the pi, the original pi. We have taken care of that phase shift, and now we are going to graph the tangent basic shape. We're going to start at the very middle and plot our point at the x-axis. We're going to go to the right and up 1 unit. That's what the original tangent function does. To the right and up 1 unit. So at pi over 2 we'll be at 1. And we want to go to the left and down 1 unit for the midpoint of 0. So we're going to go up and to the right, and then down and to the left. Remember that the A tells me how far to go from the middle of the graph to the right and up, how much to go up, and when I go to the left, this A tells me how much to go down. And the A is what we multiplied times the front of the function, which is an implied 1. We want to graph y equals cotangent of 3x plus pi over 4. We notice, just like when we encounter problems like this with sine and cosine, we notice that 3 is being multiplied times x, and we have parentheses but we don't have brackets. So pi over 4 doesn't represent the phase shift. It represents a mixture of the period and the phase shift. So let's factor out that 3, that factor of 3, to get what we're actually looking at graphing cotangent, bracket, factor out the 3, we're left with x, and we're going to multiply by 1/3. It's like flipping that fraction and multiplying by the reciprocal. That's plus pi over 12. So the b would be 3, and my phase shift would be here, the positive pi over 12. So the period is pi divided by 3, and the phase shift to the left, pi over 12 units. Now when we are looking to find out the starting and ending values, we will start with making our inequality with the original starting and ending points of the period. So that starts at an x value of 0 and ends at pi. So we want to solve for x. We're going to divide everything through by 3. 3's cancel, we're left with x plus pi over 12. Subtract pi over 12 from each part. So we end up with 0 minus pi over 12 will be minus pi over 12. Subtracting pi over 12 from the middle, the pi over 12 cancels out. And I want to subtract pi over 12 from this. In order to do that, I have to have a common denominator of 12. 4 pi minus pi would be 3 pi over 12. So, reducing my fraction, pi over 4. So here's the starting points and ending points of our one interval period of cotangent. Minus pi over 12 and positive pi over 4. These will be the asymptotes of our graph. And our midpoints, we're going to add together minus pi over 12 plus, and we need a common denominator, which is right here, plus 3 pi over 12. So we're going to add together these two. We have to give them the same denominator. We get 2 pi over 12, and if I multiply by a half, we get positive pi over 12. So that means that in between minus pi over 12 and positive pi over 12, we have 0, which is our y-axis. Now pi over 12 plus pi over 4, pi over 12 plus pi over 4, which is 3 pi over 12 when we get a common denominator. It's 4 pi over 12, multiply by a half. Keep reducing, we end up with pi over 6. So after we reduce that fraction, we get pi over 6. Now the vertical stretch comes from what we multiplied times the front of the function, the a, and it looks like a here is equal to 1. So for cotangent, we're going to start at the middle. So here's the middle of my graph. And then we're going to go up and to the left 1 unit. So here we are. So at our second midpoint there of 0, our second point, we're going to go up and to the left for cotangent. And then we're going to go to the right and down 1 unit. And that puts the y value at minus 1. So we're going to start at the middle, go down and to the right, and then go up and to the left.